Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faizal bin Muhammadin, and today I will be presenting about our PBL. I'll start with the introduction. So basically, Shannon's theorem is a general definition for noisy channel coding, or it is also known as a Shannon's limit. Input message sent over a noiseless channel can be recognized from output message. And however, when noise is introduced to the channel, different messages at the channel input can be produced at the same output message. Thus, noise creates a non-zero probability of error (PE) in transmission. The repetition code or linear error correcting code will reduce PE but also reduce the rate. So these are the example of the block diagram for a system that involving the usage of Shannon theorem. Any additional signal that interfere with the reception of information is noise. In electrical apparatus, noise comes only from within the system, whereas in human activity it may occur quite apart from the act of transmission and reception. Interference may result, for example, from background noise in the immediate surroundings, from noisy channels, such as a crackling microphone, from the organization and semantic aspects of the message, for instance, synthetical and semantical noise, or from psychological interference with encoding and decoding. Noise need not to be considered a detriment unless it produces a significant interference with the reception of message. Even when disturbance is substantial, the strength of the signal or the rate of redundancy may be increased to store efficiency.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz. So let's proceed with problem and calculation in Shannon theorem. First of all, we will go through to zero order whole or ZO. In order to get zero order whole output, we can using either Laplace transform or Z transform, but now we are choosing or using Z transform. Here we are using t equal to 0 and 0,5, k equal to 1 is constant, and our transfer function is 1 over s plus 4. Based on the system that we are using here, we can recognize it as open loop system because we got only one input and one output and two block system. See, like what I have mentioned above, our transfer function is 1 over s plus 4. Our ZO transfer function is 1 minus exponent negative ts over s. Exactly, for the ZO transfer function here, under the ZO transfer function, we got two blocks. First block is 1 minus exponent negative ts, and another block is 1 over s. We join it together or multiply it together, so it will become like this. Okay, next we will go to combine these two blocks become one block, which is we take our transfer function is 1 over s plus 4, we multiply with ZO transfer function, so the output will become like this after multiply it. Okay, next we will go, or we will assume that the first block we assume as second transfer function. We will give name G2 in a S domain. So here G2 will become 1 over S times S plus 4. We times 4 because of we need to make it exactly same in the Z transform table, because we need to change the S domain to Z domain. So we will get 4 over 4 times s plus 4. And then we will convert the transfer function, our transfer function in S domain to the Z domain by referring Z transform table. This is our S domain transfer function. This is what we can see in the Z transform table like this. This is a Z domain. After that, we are changing it, our transfer function, main transfer function, into the Z transform function, which is like we see here, we got A is equal to 4, S plus 4 is here, S plus 4, and then S here is represent S over here, and 4 we put outside from here, which is 1 over 4. So what we can see here, it will become exactly like in the Z transform table, is Z time 1 minus exponent negative A over T. A is 4, we replace it with 4 because our numerator is 4. And then Z minus 1 times Z minus exponent negative AT. A we replace with 4 because our denominator is also 4. And then we got whole number which is 4. We put here 4. Okay, next we will proceed with Zoh transfer function. After we multiply it together between the first our transfer function, which is 1 over s plus 4, with 1 minus exponent negative ts over s. After we multiply it, we assume that 1 minus exponent negative ts, which is transfer function of Zoh in S domain, we changing it ETS, we replace it with Z. So here E negative TS will become Z minus 1. So Z minus 1, it will be same as 1 over Z. 1 over Z. To get it, to make it in one number or one equation, we need to time it with Z. So it will be same at denominator. So, and then last value we will get Z minus 1 over Z. Okay, next we proceed with multiply the value of our transfer function in Z domain and the Zoh transfer function in the Z domain. So here we got it. So Z minus 1 we cancel with the denominator for transfer function domain, transfer function Z domain, and then the Z denominator for GHO Z domain we cancel out with Z over here. So the value will become 1 minus exponent negative 40 divided by 4 times Z minus exponent negative 40. After that, by using T is equal to 0.05, we replace the value T with 0.05. So you can see here, we replace it A with 4 and T, we replace it with 0.05. So here exponent negative 4 times 0.05 will become 0.8187. So 1 minus 0.8187 over 4 minus Z minus 0.8187. After that, we put the 4 is up here. We from the denominator we put under the numerator, but will be here will be time, and then here after we change it on the numerator it will become divide. So the answer will be give, or we will get 0.0453 over Z minus 0.8187.
Assalamualaikum. My name is Firdaus and I'm here to explain about the first order whole, which is the FOH. Okay. In FOH, there is input and output, and there is two blocks, which is FOH block and S domain. And this system is an open system because there is only input and output, and there is no feedback. Okay, and for our transfer function, we're given as 1 over S plus 4, which is G1S in the S domain form. And FOH, there is three blocks, which is 1 minus e to the power of negative ts square times by 1 over s times by ts plus 1 over t. And yeah, and therefore we get the S domain times by FOH block. And therefore we get 1 minus e to the power negative ts square times by ts plus 1 over ts square times 1 over s over 4. And we assume the back of the G domain and GHZ, the ts plus 1 over ts square times by 1 over s4 as a G 2s, which is function number 2 S domain in normal. And therefore we substitute, we times ts plus 1 over ts square times 1 over s or s plus 4, and therefore we get the G2s as the number 2 function number 2 as 1 plus ts over ts square s plus 4. And there we substitute the t, which is 0.05, into the general question of function number 2, and we factorize them into into partial fraction, and we solve the equation, the function number 2 in using partial fraction, which is we break into 3, which is a, b, and c. And we use partial fraction, and therefore before that there is two methods to solve this equation, which is Z transform and state space. Therefore, since we are using Z transform, they will be using the Z transform method. And we cut them into 3, which is we get A, B, C. And for A, for every part of this one, A, B, and C, we have to times by the number that like example, A must times by s square plus s plus 4 for B. Therefore we have to times by s square plus s plus 4, and C s square plus s plus 4. And therefore we will get this one, s plus 20 equals as s plus 4 plus b s plus 4 and c s squared. And for we can cut for the denominator because it's same, and we only take only that has the same number, which is 20. And for because 20 equals 4b, because there is no s, and therefore b is we will get equals to 5. And for this one, we assume s equals to negative 4 as denominator root, and therefore we will get the c is equals to 1, and we substitute the value of b and c to find a. So first thing, we substitute the b and c, and then we expand, and we factorize, because on the left side there is no s square, but they only it only have s, so we assume that s equals to 1. So and therefore, since s equals to 1, negative 4 equals to 4a, and therefore a is will get to negative 1. And we substitute the ABC into the general question, which is the ABC G2, and we will got negative 1 over s plus 5 over s square plus 1 over s plus 4. And we substitute the e to the power exponent to the power of ts into GHZ, which is 1 minus e exponent to the power of negative ts square. And how we get this z minus 1 square over z square is because uh, since z to the power of negative 1 is equivalent to 1 over z, so we have to we have to make the denominator same, so therefore 1 is equivalent to z over z. So when it's combined, it will become z minus 1 over z, and therefore as we expand the value of we insert the value of square, therefore we will get z minus 1 over z square. Okay, and since this one z minus 1 over z square is no longer as a z as domain, it will become z domain because you already substitute the z. And then we con- g con- convert the value of g, the transfer transfer function number 2, into z transform table. So as you can see, the value of negative 1 over s is equivalent from the z transform table is equivalent to z over z minus 1. Why we get negative z is because the real equation is negative 1, so we have to put the negative on the z. And for 5 over s square, we put the 5 outside, and the general equation is 1 over s square, and from the z transform table is equivalent to tz over z minus 1 square, and therefore we get 5 bracket tz over z minus 1 square. And for 1 over s plus 4 is equivalent from based on the z transform table is equivalent to z over z minus exponent to the power of negative 4t. So this for equation z number 2, we will get this one, negative z over z minus 1 plus 5 bracket tz over z minus 1 square plus z over z exponent to the minus exponent to the power of negative 4t. And then we substitute the value of t 0.05 to the general question. And since we already got the G2 in Z domain and FOH transfer function in Z domain, so we just substitute, and this one we substitute. And first of all, on the right side, which is the G to Z, we have to we have to simplify and make the denominator same. So therefore we will get this one as the simple one. And then for the GHZ, that is the same as like before this. Because of z to the power negative 1 is equivalent to 1 over z. Therefore, we simplify, we will get z minus 1 square over z square. And therefore, we will expand this one. We will multiply each other. and we will multiply, and therefore we will get the final answer for our FOH is equivalent to 0.0687Z minus 0.023375 over Z bracket Z minus 0.8187. So this is our FOH.
Okay, next we move to the MATLAB analysis. Firstly, we generate the zero order hole, which is, as we know, zero order hole is a exact discretization in the time domain for staircase input. So this is the MATLAB work. Firstly, we need to generate the transfer function, which is we need to insert the numerator and denominator. And this is the transfer function, which is 1 over s plus 4. And then we need to generate gs, which is gs equal to c to d. C to d is stand for convert model from continuous to discrete time. And then we need to put the gz 0.05 for sample time and ZOH for zero order hole. And then we get G as 0.0.04532 over Z minus 0.8187. And next we need to generate the output graph. Firstly, we need to step GZ and then step GS, and then we need to step both step GZ and GS. And this is the zero order hole graph. Next, we move to the first order hole. As we know, first order hole is the exact discretization in the time domain for piecewise linear input. Firstly, same as zero order hole, we need to generate the transfer function, which is 1 over s plus 4, and then we generate gs equal to c to d, and insert the value for gz 0.05 for sample time and FOH for first order hole. And then we get GS 0.0687Z minus 0.2338 over Z squared minus 0.8187Z. And then we need to generate the output graph. Firstly, we need to step GZ, step GS, and then step GZ and GS. And this is the output graph for first order hole graph.
Thank you, Haziq. So, as a conclusion, to convert a continuous time signal to a discrete time signal and vice versa, sampling theorem is a fundamental factor that need to be considered in digital signal processing so that the output signal does not deviate so much from the input signal. Reconstruction of the Shannon sampling theorem occurred when the criterion of sample rate is not met. With respect to this reconstruction can be executed by zero order hole or first order hole. Both of these methods imply the same function in which they are both changing over the discrete time signal into the continuous time flag. Due to that, the recreation might be done by using either of these methods. Both comprise of the same strategy of calculation but diverge within the equation condition for zero order hole and first order hole before changing into the theorem. The higher the order of derivative, the more precise the reconstruction. However, it is regularly reason for a serious stability difficulty. That's all from us. Thank you so much. Selamat Hari Raya Aidilfitri. Maaf zahir dan batin.